Let's live it up. We only get one life. We only get one life. One life like this. Like this. Let's live it up. Clap your hands. We only get one life like this. Let's live it up. Clap your hands.
Holding on to what I know, to everything I've learned, what is real and fabricated. What is wrong? What is my problem? How can I get out of this world that I created? Fighting the storms in my head, don't know where I have been. I'm alone, no one to turn to, no one understands. Shit's too complicated. Away, and I feel like I am someone else. Away, and I feel like I don't know myself, no. Away, and I feel like I don't know my name. And I don't want to live this way. I don't want to keep on wasting a life. I'm drowning in my head, I'm losing the mind. And if you could know, yeah, if I could show you, I don't wanna keep on living this life so faceless.
Unknown Brain, Marvin Devine,
And we back.
Can't nobody tell me nothing. Made it through the wind and rain, I turn nothing into something. No more dealing with their assumptions, cause I do what I gotta do and I know, can't nobody do it like me. All they do is judge me for who I might be. Maybe if they took some time to pick my mind, they see that I'm cooler than lemons and iced tea. All I wanna do is live it up with the homies. Everybody really talking as if they know me, but I guess I gotta face it. I'm so tired of being faceless.
I don't wanna keep on wasting life. I'm drowning in my head, I'm losing the mind. And if you could know, yeah, if I could show you, I don't wanna keep on living this life so faceless.
So faceless.
I got a premonition, I'm dreaming you and I. All my darkest fears are coming outside. We got a billion races, we got this melody. And you can trust me, baby, we got everything. Call me whenever you feel alone, babe. And when you need to cry, I'll be by your side. Call me whenever you need someone, babe. And when you need to escape from 1,000 fires, I'm gonna kiss you wherever you are. And I'm gonna miss you, I will never lie. Call me whenever you need someone, babe. We're running in the jungle of love. I got you on my mind. You were stuck in my head and I don't know why. We got a billion races, we got this melody. And you can trust me, baby, we got everything. Call me whenever you feel alone, babe. And when you need to cry, I'll be by your side. Call me whenever you need someone, babe. And when you need to escape from 1,000 fires, I'm gonna kiss you wherever you are. And I'm gonna miss you, I will never lie. Call me whenever you need someone, babe. We're running in the jungle of love.
I remember the days, always at the same place, the same people every day. I will never forget this black old Corvette standing in front of my way. We were both in high school. I thought I was a fool. Oh, when I was falling for you. You keep drawing me in, and I know it's a sin. But even so, yeah, I need you. You taste like candy. Eat you on a Sunday. Feels so bittersweet, knowing I can leave. You taste like candy. Eat you
Alright, good afternoon. Everybody should be in a gear day. Day 3. Yeah, looking like day 3 today. Right, who did? Am I here? We seen. Right, today we're on into this Specimen Paper 2. Now, I hope everybody have it. If you have it, you should have it. Now I run through the question. Looking easy. I just give it a little quick run through. Looking easy. Again, I don't want to put no things on the screen because copyright. So I'll let you just follow in all the books or follow in all the notes for the questions and see what solutions we do now. Give me a second. Hopefully this making sense. You go see how much sense this making, right? Some quality of life, right? Good afternoon, Aaron, Yanis, Sammy. Alright. Starting. So there we go. First question. 1A. 1A part 1. Determine the remainder when f of x is divided by x plus 1. Well, f of x over x plus 1 is equal to f of minus 1. And this is equal to 2 into minus 1 cubed plus b into minus 1 squared plus 2 into minus 1 plus 5. Everybody have the specimen paper? You know I could do this. Yeah man, I could do that. Bring that there. Put this here. Make this bigger. Nice. Put this at 100. Cool. Alright, so work this out. F of minus 1 is equal to, this could be minus 2 minus b minus 2 plus 5. So f of minus 1 is equal to minus 2 minus 2 is minus 4, minus 4 plus 5 is 1, so we get 1 minus b. Now we are done there. Here the code remainder factor theorem. We state that if a polynomial f of x is divided by x minus a, then the remainder is f of a. If f of a is equal to 0, then x minus a is a factor of f of x. Alright, so quick question. Is the audio coming through to you all loud and clear? Or is it a little soft? Or is it too loud? I just want to know, so I got adjust it accordingly. Part 2. If the remainder when f of x is divided by x minus 2 is equal to the remainder in a part 1 above, calculate the value of b. Alright, so the remainder here is 1 minus b. The question says that this is the same remainder when the function is divided by x minus 2. So we're performing the same operation. F of x divided by x minus 2 is equal to f of 2 is equal to 2 into 2 cubed plus b into 2. Oh, it's plus b. Sorry, it could be plus b. Minus 1 squared is plus. Alright, 2 into b squared. B into 2 squared, sorry. Plus 2 into 2 plus 5. F of 2. 2 2s are 4, 2s are 8, 2s are 16. Plus 4b. Plus 4. Plus 5. F of 2. 16 and 4 is 20. And 5 is 25 plus 4b. Interesting. So we have, from the data, f of minus 1 is equal to f of 2. Which means 1 plus b is equal to 25 plus 4b. Rearrange a little bit. I get 1 minus 25 is 4b minus b. 1 minus 25 is minus 24 is 3b. And b is minus 8. Easy peasy lemon squeezy. Regular paper. This is specimen paper. It is on the syllabus. If you want it, message man, I will send it to you, Kyle. Or anybody in your class, Sammy, if you can send it to Kyle, send it to him. Part B. This is specimen paper 2020-2021. Part B. G of x is equal to, right, x squared plus m minus 3 x plus 2m plus 1 is equal to 0 has real roots when b squared minus 4ac is greater than or equal to 0. Determine the range of values for m. So these are discriminant question, but the thing I do like about this question, it should have said real and distinct. They should have said real and distinct roots. Right, so nevertheless they give us information. A is 1, B is m minus 3, and C is 2m plus 1. B squared minus 4ac is greater than or equal to 0. Just do a little substitution. M minus 3 squared minus 4ac is greater than or equal to 0. M squared minus 3m by 2 is 6m plus 9 minus 4 2s are 8 minus 4 is greater than or equal to 0. M squared minus 6 minus 8 is minus 14, and 9 minus 4 is 5. It's m minus 3x, 2m minus, oh, it's 2m minus 1. Okay. 2m minus 1, I take down the question wrong. So it's 2m minus 1 here. So this could be plus 4. 9 and 4 is 13. Good. So a by c is 1 by 13, which is 13. The factor is going to be minus 13 and minus 1. M squared minus m minus 13m plus 13 is greater than or equal to 0. M into m minus 1 minus 13 into m minus 1. M minus 1 into m minus 13 is equal to 0. And we get m is equal to, sorry, greater than or equal to 0, greater than or equal to 0, or m is greater than or equal to 13. Represent with two solutions on the number line. Don't forget to say let the number line be so by so. Let the number line be so by so. My two solutions are 1 and 13. This is section 1, this is section 2, this is section 3. In section 1, it's x is less than 1. Section 2 is x is greater than 1, as well as x is less than 13. So when I combine them, I get minus 1 is less than x is less than, 1 is less than x is less than 13. And in section 3, x is greater than 13. At testing, x is equal to 0 in my inequality. In the inequality, I will get 13, well, I will put 0 squared minus 14 into 0 plus 13 is greater than or equal to 0. So we get 13 is greater than or equal to 0. This is true. So therefore, no, I wouldn't say that yet. 0 is in 1. So therefore, 1 and 3 is satisfied. So the solution will be x is such that x is less than or equal to 1, union the set of values of x such that x is greater than or equal to 13. That's it. Part C. And this is C part 1 and stuff, right? H of x be 3x squared plus 12x minus 8. 3x squared plus 12x minus 8 minus 18, sorry. Express h of x in the form so by so, so by so, and so by so. I will perform the same solutions we did, I think, in day 1, where we completed the square. Or was that in maths? Probably it was in maths. So we'll just be comparing the coefficients. So I'll have 3x squared plus 12x minus 18 is equal to a into x plus b squared plus c. I expand in the right side all the way. 3x squared plus 12x minus 18 is equal to a into x squared plus 2bx plus b squared plus c. 3x squared plus 12x minus 18 is equal to ax squared plus 2abx plus ab squared plus c. Equate corresponding coefficients. For my x squared coefficient, I will have 3 is equal to a. For my x coefficient, I will have 12 is equal to 2ab. So 12 over 2a is equal to b. 12 over 2 into 3 is equal to b. 3 2s are 6. 12 over 6 is 2. 2 is equal to b. So, let's put this on silent there. I just now go send the paper to all the rest now, right? My constant is minus 18 is equal to ab squared plus c. Minus 18 minus ab squared is equal to c. Minus 18 minus 3 into 2 squared is equal to c. This could be minus 18. Take away 2 2s are 4 and 4 3s are 12. So c is equal to, what is that? 1 2 3 minus 30. So h of x is equal to 3x squared plus 12x minus 18 is equal to a into x plus b squared plus c, where a, b, and c are constants. They should have said where a, b, and c are constants in the question. State the minimum value of h of x. Part 2. This part 1 here. Part 2. Say the minimum value of h of x. The minimum value of h of x of any function occurs at x is equal to, well, at k. Occurs at k. In this case, it will be c. So the minimum value of h of x occurs at c is equal to negative 30. Alright, so let me just send this to already. Alright, the paper questions is on page 86. That's where the specimen paper is, page 86. So, part 3. Determine the value of x for which h of x is a minimum. So, h of x is a minimum when x is equal to, in this case it will be b, which is equal to 2. Okay, we have our next question. Nice looks question, it's looking like. 2, part A. Given that tra-la-la-la-la-la, find the value of a. Okay. So we have log of 4 minus root 8 to base 2 minus log of 2 minus root a to base 2 is equal to log of 5 to base 5. Alright, no problem. So wherever we use our law of logs, I like to recall the law. So I'm going to recall my second law of logs here. I'm going to recall log of m to base b minus log of n to base b is equal to log of m over n to base b. Also, log of a to base a is equal to 1. And this works both ways. So on the left hand side of the equal sign, I will have log of 4 minus root 8 over 2 minus root a to base 2. Now on the right hand side, I have a different base. But remember, this is of the form log of a to base a. So this is 1. I can also write this as log of 2 to base 2 to bring all the bases to be the same thing. So this could be log of 2 to base 2. We say this is a log equation. Remove log to base 2. So I'll have 4 minus root 8 over 2 minus root a is equal to 2. Cross multiply. 4 minus root 8 is equal to 2 into 2 minus root a. 4 minus root 8 is 4 minus 2 root a. 4 minus 4 is 0. 4 minus 4 minus root 8 is minus 2 root a. 4 minus 4 is 0. So I get minus root 8 over minus 2, which is root 8 over 2 is equal to root a. If I square both sides, I will get root 8 over 2 all squared is equal to root a all squared. Root 8 squared is 8 over 4 is equal to a. A is equal to 2. Right, part B. I could do part B right here. Find a set of values of x for which 3 minus x over 2x plus 1 is less than 0. Again, we better show you working, eh? Multiply by 2x plus 1 to be squared. I get 3 minus x into 2x plus 1 to be squared all over 2x plus 1 to be squared is less than 0. Sorry. Into 2x plus 1 to be squared. You cancel with 1 or you on top. So I remain with 3 minus x into 2x plus 1 is less than 0. 3 minus x is less than 0. I get 3 is less than x, which means x is greater than 3. At the end of the day, I don't really business about the signs right now in my solutions. I am businessing with the solutions itself, the numbers. So I business with the 3, and on the next side, or 2x plus 1 is less than 0, x is less than minus a half. I'm businessing with the 3 and the minus a half. I don't care about the signs as yet. Represent these fellows on a number line. Okay, number line nice and big. Let the number line be so by so. I have here minus a half. I have here 3. This is section 1, section 2, section 3. In section 1 is x is less than minus a half. Over here is x is greater than minus a half. And x is less than 3. Combining both of them, minus a half is less than x is less than 3. And in section 3, x is greater than 3. So I'm going to test x is equal to 0 in my original inequality. So I get 3 minus 0 over 2 into 0 plus 1. Supposed to be less than 0. I get 3 is less than 0. This is not true. 0 is in section 2. 0 doesn't satisfy the inequality. So therefore, 1 and 3 is satisfied. So my solutions will be x is such that x is less than minus a half, which is in section 1, union the set of values of x such that x is greater than 3. And you're good to go. Right now, I see in this specimen paper, we have 2 questions that come as inequalities. So I most likely believe that they go test inequalities a little heavy based on the paper. So just be prepared for the inequalities question. Now, it have more than one way to solve these types of inequalities here. Whichever way you like, you can go ahead and do so. If you like to draw a graph and go ahead and figure out where you like to do it, go ahead. If you want more detailed explanation on this method, let me know. I'll make a video and put it up. Don't wait till last minute. I'm not going to make it last minute and hustle along myself, hustle along all yourself. Part C. John deposited $5,000 at 12% per annum into his bank. The bank's compounded interest is represented by the geometric progression. The amount is equal to P into, alright, this is the compound interest formula. Determine the number of years it would take for John's money to at least double. At least double could be... This is an interesting question here, boy. How much marks this with? And I still 6 marks. Alright, so John, he deposit. so by so, a 12% per annum into his bank. The bank's compounded interest represents geometric progression, so by so. Okay, so at least double, this looking like our next inequality here, yes? So the amount is equal to principal into 1 plus r over 100 to the power t. We know the principal, 5,000. 1 plus the rate is 12% to the power t. We don't know the time. But we do know that how we want this figure here to be at least double. So it must be at least doubled. It must be more than or equal to 10,000. Have to be more than or equal, because if it's at least double, it can be double or more. Rearrange it a little bit. You get 1 plus 12 over 100 to the power t is greater than or equal to 2. Yeah. We gotta take a log. Here what I going to do? I'm going to let it equal to 1,000. And in the solution, let me see what we get. If I let it equal to 10,000, because that's at least double the money. Yeah. So I like to take ln. Take ln on both sides. Get ln of 1 plus 12 over 100 to the power t is ln of 2. Recall log of a to the power c to base b works both ways is c log of a to base b. So I have t ln of 1 plus 12 over 100 is equal to ln of 2. T is equal to ln of 2 divided by ln of 1 plus 12 over 100. So I'm going to work out what that is. My calculator. 1 plus 12 over 100 is 28 over 25. So I have ln 2 divided by ln of 28 over 25. We get 6.11 years. So t is equal to 6.12. Now this will be the number of years for the money to be doubled. So if they want the number of years for the money to be at least double, at least could be strictly greater than. So it'd have to be greater than 6 years, which could be 7 years. Because compounded interest is calculated per year. Right? So there's 6.12 years, which is 6 years to the nearest year. So therefore, for John's money, to be at least double, the time must be 7 years. Because after 6 years, I just not going to respond to that question. After 6 years, it is actually a little less than double. After after this much years, the 6.12, after this much years, wait here, after this much years, it is exactly doubled. So after 7 years, it will be more than doubled. Does it have a base? Yes, ln has a base. Ln is log to base e, just like how lg is log to base 10. Ln is log to base e. Lg is log to base 10. These are two functions that are easily found on the calculator. Alright, I'm saying at least 7 years. If you want to say at least 7 years, you can go ahead and say so. But I think for John's money to be at least double, t has to be equal to 7 years for it to be at least doubled. If it have to be more than doubled, I will say then it will be greater than 7 years. Right? Or at least 7 years if it's more than doubled. Right, next question. Circle. So you should know about here already, man. Moving with tidal speed. A circle has center C minus 3 minus 4. Okay, so the center of a circle is minus 3 minus 4. A point P is on its circumference. Determine the equation of the circle expressed in the form x squared plus y squared plus ax plus by plus c is equal to 0. Now, it have two ways you can do this, right? The first way is by knowing how to manipulate your equation, x squared plus 2fx plus y squared plus 2gy plus c is equal to 0. Now, because the question give it in such a way that you have a's and b's there, it will tend to be a little bit confusing. But don't worry, we have the next form for the equation of a circle. X minus a squared plus y minus b squared is equal to r squared. Let me see what we can do with that. We know that how x minus a squared plus y minus b squared is equal to r squared is the equation of a circle. I don't mind taking the extra 2 minutes and doing it like this, where a comma b is the center and r is the radius. Now, given that we have the center of the circle already, I can substitute those numbers inside of here. So the center is a and b. So if I have x minus 3 squared plus y minus 4 squared is equal to r squared. AB is the center of the circle, where a is minus 3 and b is minus 4. You just have to be very, very careful when you're writing down the equation of your circles, regardless which form you're using. Now we got to figure out what the radius is, and we know that out from the center to a point on the circle, that is the radius. So let me see what's going on here. So if C is that and P is equal to 5, 2, we know that the length of CP will give me a radius. So we go work out this now. So this here becomes x plus 3 squared plus y plus 4 squared is equal to r squared. Now we know if you come in, you can come in a working column here, and you can say that, oh well, here is the scene. The modulus of CP, or the length of CP, is the radius. So the length of CP is equal to, write down your formula, x2 minus x1 squared plus y2 minus y1 squared. Label your stuff, x1 y1, x2 y2, x2 minus x1 squared plus y2 minus y1 squared. Skip a line. Remember, it's the square root of all of this, huh? There's 5 and 3 is 8. 8 squared is 64. and 4 and 2 is 6. 6 squared is 36. We get root of 100. So the radius is 10. So my radius is 10. So we have x. Actually, I could just rub this off here one time. My radius is 10 squared. Now I can go ahead and expand, simplify, and bring it in the form that they want us to. And remember, you're allowed to use the shortcut to expand the square bracket. If you don't know it, go ahead and expand it long ways now. X squared plus 6x plus 9 plus y squared plus 8x plus 16 is equal to 100. So to have x squared plus y squared first. X squared plus y squared. They have plus ax plus by. No, that's 8y, sorry. Plus 8y plus c. Now c go be 9 plus 16. Take away 100 is equal to 0. X squared plus y squared plus 6x plus 8y plus 9 plus 16. Ugh. Take away 100 minus 75. Minus 75 is equal to 0. Is of the form x squared plus y squared plus ax plus by plus c is equal to 0, where a is equal to 6, b is equal to 8, and c is equal to negative 75. Did they say that they are constants? But you can say that they are constants, where a, b, and c are constants. Nothing wrong with that. Right, and if you want, you can go and double check it now by using your long formula. That will be minus 2fx, that will be minus 2 into minus 3 and minus 4. So yeah, that's the answer. We're good to go. Alright, we have a tangent now. Determine the equation of a tangent to the circle at the point P, 5, 2. Alright, don't be correct, right? 5, 2. Good. So part 2. Brother man, I want to give the tangent a name. Let the tangent at P be x, y. We know that how the gradient of x, y, symbolized as common m subscript xy, multiplied by the gradient. I mean, it has more than one way to say it, right? I'm just doing this for a little diversity. Multiplied by the gradient of cp, represented as m subscript cp, is equal to minus 1. Because the product of gradient of perpendicular lines is equal to minus 1. We want the gradient of xy. We can calculate the gradient of cp because we have enough information to do that. So the gradient of xy is minus 1 over the gradient of cp. If you wanted to do it like this and then state product of the gradient of perpendicular lines is minus 1, no problem. Big up yourself. So we calculate the gradient of cp. I could do that in my working column again. The gradient of cp is y2 minus y1 over x2 minus x1. y2 is 2. Let me just copy this here and bring it up. Oh, good lord. I just copy in C and P so we could see them easily downstairs there. And I recommend you actually write out your points as well. Bring this down a little bit. Write out your points and have them on standby, just like this here. y2 minus y1 over x2 minus x1 4 and 2 is 8. 5 and 3 is 8. So the gradient of CP is 1. So the gradient of xy is minus 1 over 1, which is minus 1. Not bad. The equation of xy using the point P, because P is the point on xy, this becomes my x1 and my y1, is y minus y1 is m into x minus x1. Y minus y1, which is 2, is m into x minus x1. Move everything across one time. Y is minus x plus 5 plus 2. Y is equal to minus x plus 7 is of the form y is equal to mx plus c, where, oh shucks, my bad, I multiply 3/4 haloxy. So let me do this over one time. So bear with me, right? All your responses is coming a little while after, so the working would be plenty when I see the little mistake. So this could be minus 1 divided by, let me just double check it again, 4 and 2 is 6, 5 and 3 is 8, 3/4 divided by 3/4, which is equal to minus 1 multiplied by 4 over 3, which is minus 4 over 3. So this here is minus 4 over 3. Same thing, y is equal to minus 4 over 3x plus, that is 20 over 3, plus 2. 20 over 3 plus 20 over 3 plus 2, 8 and 2/3, or 26 on 3. Is of the form, and I'm gonna show you how to, well, I'm gonna double check it, right, to make sure. Is of the form y is equal to mx plus c, where m is the gradient, is minus 4 over 3, and c is the y-intercept, which is equal to 26 over 3. Now you see how I write in little statement and thing, and that is not for papi sure, that's for marks. Although it might count as a little physical mark, it could count as a mark towards your distinction at least. Right, let me have these two things here now. So let me so write down the equation of the circle now. The equation of the circle, we worked it out to be x squared plus y squared, x squared plus y squared plus 6x plus 8y plus 16, no, plus minus 75 is equal to 0. Right, we got a circle there. I'll go in and plot the point P. P has coordinates 5, 2. Oh shit. Hey, so it just so happened P is on the circumference of the circle, so we're good to go so far. Oh, and that is one thing you all can do to double check your work, eh? If you want to double check your equation, they say that our P is a point on the circle. All I have to do, substitute the coordinates for P in the equation you calculate and see if you get equality. So for example, if I plug in x is equal to 5 and y is equal to 2 into the equation of the circle, I will get 0 is equal to 0. That's how I know P is on the circle. If I plug in the equation of the tangent over here, I should get the line passing through A. minus 4 over 3x, y is equal to minus 4 over 3x plus 26 on 3 over 3. So we good to go. Next question. Vectors. This part B, part 1. Yeah, big question, boy. How much marks this one worth, boy? It have a part C and all. 20 marks for number 3, boy. The testing plenty things. Alright, so number 3, the testing plenty things in it earlier. Number 3, the test circles. The test a little coordinate geometry. The testing vectors. The testing trigs and surds. Papayoi. Alright. We are frightened. That is one thing I did tell all my students. We are frightened. We get them. The position vector of 2 points A and B relative to a fixed origin O are. Now given that it's position vectors, I know it's OA and OB they're talking about. So I'm not going to write A is equal to that. I'm going to write OA is equal to minus 4, 6. And I'm going to write OB is equal to minus 3, minus 4. A point P lies on OA such that OP is equal to PA. That means P is the midpoint of OA. So P, if OP is equal to PA, this means that P is the midpoint of OA. I don't know if you're going to help me, but whatever information I can gather from the question, I'm going to write it down. Determine the vector BP. Now, I tell all my students this. Easiest thing to do, draw a diagram. A diagram is your best friend. So let me have a little meeting with your best friend here. It's just a little quick sketch, nothing too fancy. So minus 4, 6 could be up here. That is A. Draw my vector to A. My arrow. P is somewhere here. O. Minus 3, minus 4 could be somewhere down here. This B. I want this here. BP. Yeah? Just draw a quick thing, that is all. So the common point between B and P is O. So I know that at one time this is part 1. BP is equal to BO plus OP. BO I don't have BO, I have OB. BO is negative OB plus OP is half OA, and I have OA. We have OB, which is negative 3, negative 4, plus a half OA, which is minus 4, 6. Scalar multiplication is just like you're multiplying it by a bracket. You multiply it by everything inside the bracket. I'll simplify the first one here. Minus 1 by everything inside could be 3, 4, plus a half of 4, minus 4 is minus 2, and I get 3. Add corresponding components, I get 1, 7. Yeah, makes sense. Alright. Second part. Determine in its simplest form the magnitude of the vector BP. Well, we already calculate BP, so to calculate the size of it, real simple. Part 2. Magnitude of BP could be the square root of the I component plus the square root of the J component 1 squared plus 7 squared root 50. Now they said in its simplest form, so don't leave it as root 50. We had to simplify this. The root 2 root 25, which is 5 root 2 units. So you see we end part B in surds and we entering part C in surds. So the question is constructed very, very nice, I will say. Although it might be a little tedious or something, I just want a little to take all the time. Nice one. Given that tan of pi on 4 is 1, tan of pi on 6 is root 3 on 3. Without the use of a calculator, evaluate tan of pi on 12 in its simplest surd form. No scene. What are we doing here? Same thing like yesterday. Write down the information I have. Tan of pi over 4 is equal to 1. And tan of pi over 6 is equal to root 3 over 3. Come in your working column here. How I remove the minus sign for OB? I'm going to adjust that one time. I distributed the minus sign inside of the brackets, Kyle. So minus by a minus is a plus, minus by a minus is a plus. Just like how I distributed the half into the bracket here, a half of minus 4 is minus 2, and a half of 6 is 3. This is minus 1 outside here. It's just we don't write the 1. Right, back to this one now. Right. Jump in your secret working space. CSEC not seeing this. This is the secret, the top secret working. It is classified. Pi on 4 is 45 degrees. You can check it out and see. I'm going to do the calculations. Pi on 4 is pi on 4 multiplied by 180 over pi. Bam bam. 180 on 4 is 45 degrees. Pi on 6 is pi on 6 multiplied by 180 over pi. Bam bam. We get 30 degrees. Now, I want to know how we're going to get, well, let me figure out what pi on 12 is first, sorry. Pi on 12 is pi on 12 multiplied by 180 over pi. Bam bam. 12 into that looking like 15 degrees. So I want this by using these two angles. I mean, straightforward, this is a compound angle formula. I just need to know how I'm breaking up the angles. And we know how to break up angles in degrees. It's a little difficult to break up angles in terms of radians, like this. But I know that how 45 degrees take away 30 degrees is equal to 15 degrees. So I already have the breakdown of how I'm going to separate my angles. 45 degrees is pi on 4 minus pi on 6 is equal to pi on 12. So I know how I'm breaking up my angles. So tan of pi on 12 is equal to tan of pi on 4 minus pi on 3. To me, this is the easiest way to do it. I'll recall my compound angle formula for tan. Tan of A minus B is equal to tan A minus tan B over, or is it plus? I think it's plus. I'll check it over just now, right? We have a formula sheet. 1 minus tan A tan B. Right? I'm just going to give it a quick double check here. Right. So plus is plus. Good lord. Plus is plus. Minus is minus on top. Okay, so it corresponds with the top. Minus and a plus. Yes, Sammy, you could do it like that. Nothing wrong with that. But remember, that is with top secret working. Nobody had to know that. Alright? And now it's just a basic substituting values now. We have tan of pi on 4 minus pi on 3 is equal to tan of pi on 4 minus tan of pi on 3 over 1 plus pi on 4 multiplied by pi on 3. Pi on 4 is 1 minus root 3 over 3 divided by 1 plus 1 into root 3 over 3. Don't frighten. It's looking nasty. Don't frighten. Let me deal with the numerator first. Consider 1 minus root 3 over 3. I'm going to bring this to a single fraction. There's 3 minus root 3 all over 3. Next, I'm going to consider 1 plus root 3 over 3. This is 3 plus root 3 over 3. My numerator divided by my denominator. 3 minus root 3 over 3 divided by 3 plus root 3 over 3 is equal to 3 minus root 3 over 3 multiplied by all over 3, sorry, 3 over 3 plus root 3. You cancel with you. I get 3 plus root 3 over, sorry, minus over 3 minus root 3 plus, sorry. Now, I don't want nobody canceling things here, right? Please, for the love of God, don't cancel nothing here. They said in simplest third form. Now, we can't simplify this even further by rationalizing. But, I mean, given that the question already took so much to do for a 6 marks, I think this is fine. If you want to rationalize it, you can go ahead and rationalize it. I will rationalize it out. Alright? But I think up to this point, it's fine. So I'll do the rationalization in a different color, right? Multiplied by 3 plus root 3 over, sorry, minus root 3 over 3 minus root 3. So my numerator becomes 3 minus root 3 all squared. And my denominator is my difference of two squares, which is 3 squared minus root 3 squared. I can expand the top. That is 9 minus 3 root 3 by 2 is 6 root 3 plus 3 all over 9 minus 3. 9 and 3 is 12 minus 6 root 3 all over 6. And this could be 6 into 2 minus root 3 all over 6. And that is 2 minus root 3. So I mean, looking at it now, I rationalize it, right? Rationalize it. Pi on 4 minus pi on 6. Yeah, pi on 6, sorry. I mean, nice small thing, right? I just make a visual error. Pi on 6 is root 3 on 3. Right, my bad. So again, I'm going to reiterate that. Pi on 6 is root 3 on 3. I didn't make a mistake in terms of calculation. I just make a visual mistake. That is it. Alright? So, sorry about that little mistake there. We could double check we work. Right? We could double check we work. Watch. They want to know what tan of pi on 12 is. If tan of pi on 12 is the exact same thing as 2 minus root 3, if I take them away from each other, I'm supposed to get 0. So I put my calculator in radians. Tan of pi on 12, take away 2 minus root 3. Supposed to get 0. I have 2 minus root 3. God, sometimes the calculator does do this. I don't know why my calculator is being mad so, but this is correct, right? It is correct. It have some calculators, I don't know for some reason why the sharp calculators just give this problem for very, very, very small calculations in terms of things real close to 0. It does always give you an answer looking like this, right? But bet your bottom dollar this is the correct answer. So if you go to double check your work and you're seeing something mad like this, please don't be too worried. Just give your work in a little quick double check and it should be good to go. Alright, so that is it for number 3. Number 3 was a pressure question, boy. A serious pressure question number 3 was. Number 4 now. Alright, we reach easy zone now. Calculus. Differentiate 2x sine 2x with respect to x. No scene. First things first, I don't have a y. Let y equals 2x sine 2x. One time you can say is of the form y is equal to uv, where u is equal to 2x and du dx is equal to 2 and v is equal to sine 2x. Now be careful, dv dx is equal to 2 cosine of 2x. If anybody needs a little review on how to do differentiation of trigs, say so. I see Amanda say to do over the inequalities video. I will do it over. I'll put it up on YouTube. Amanda asked me to do kinematics, where we differentiating going down and integrating going up. I will do a quick thing on that. If you need me to do a quick thing on the trigs, let me know. I will put it up. Now me diving too much in depth into trigs. I'm just going to do a little calculus and trigs. Oh shucks, why put in part B for? dy dx is equal to v du dx plus u dv dx, and we say this is the product rule. V multiplied by du dx plus u multiplied by the v dx. Now too much times I see students multiply this by this. Your angle in a trig, that's secret stuff. We don't touch that. We don't perform no operations, no external operations on an angle. The only time we will perform operations on an angle if it's included inside of the angle. So please do not multiply that 2 by the 2x. That 2 goes in front of the sign. So this is 2 sine of 2x plus 4x cosine of 2x. I don't see why we can't leave this like this, right? There's just 2 marks for this. Jesus Christ, I leave in it just so. Me I go and show off. I could factorize it and I can see how I can use a double angle formula if it was worth more marks. It worth 2 marks, but I'm gonna leave it just so. Part B. A function given by y is equal to px squared plus qx plus r has a gradient 6x minus 6 at a stationary value of x of that's supposed to be x is equal to minus 2. Using principles of differentiation, find the values for the unknown variables p, q, and r, and hence determine the... Oh, good! Bye! Best CXC hold on and beat all if I get a question like this, boy. High pressure. But like I say, we are frightened. So it has a gradient 6x minus 6. So we know that our dy dx is my gradient function, which is 6x minus 6. At a stationary value of minus 2, I can only assume that the stationary value is my x value. So I write down all the information I have. My stationary value is equal to minus 2. I'll put in x is equal to minus 2. Right, again, this one here, I'm making an assumption. Let me see how the solution unfolds, so we can know if your assumption was true or not. Now, if I have dy dx and I integrate it, I will get y. Similarly, if I have y and I differentiate it, I will get dy dx. So I'm going to see how I can approach this question from two ends. The first end is, they said using principles of differentiation. Okay, so we cannot use integration here, right? But we could if we wanted to. And I will see if there's enough information. I'll do the solutions with integration to see if there was enough information to do it. So we know that how y is equal to px squared plus qx plus r. So dy dx is equal to 2px plus q. The information said that how this fella here, it has a gradient of 6x minus 6. So I'm going to let 6x minus 6 be equal to 2px plus q. If you realize, I have a certain number of x's on one side and I have a certain number of constants on the other side. So I can equate them. So I can equate coefficients, corresponding coefficients. This is a very tricky question to get tied up with, like a Sunday crab. Equate corresponding coefficients. I get 6 is equal to 2p. I get p is equal to 6 on 2, that is 3. I see my x coefficient here, I'm a constant here. My constant is minus 6 is equal to q. So I get p and q already. Time to figure out what r is. And I mean, that I no seen. I think it's not no seen. So let me follow out what we have so far. So far we have y is equal to 3x squared minus 6x plus r. Yeah, we know that one. The value of the derivative is 0. By watching it here, right? If I put 2px plus q is equal to 0, and I put that is equal to 0, I go get, I get nothing with r. I'm not getting nothing with r. To figure out what r is. If I substitute x is equal to 2 into that, 6 into minus 2 is minus 12 minus 6. So when that is equal to 0, when dy dx is equal to 0, I get my stationary point. My x value for my stationary point will be 1. So I really don't like the wording in this question, you know. Has a stationary value of minus 2. This means that minus 2 is a point on the curve. Yeah, I was thinking that, Salim. But this whole stationary value thing, it kind of threw me off now. So my stationary value is not x is equal to minus 2, so my assumption was wrong. I most likely believe my stationary value go be my y value. I'm most likely going to believe that. Alright, so let me continue here. Yeah, so this is a nasty kind of question, right? This might be a little time consuming question. This part B is worth 6 marks. I will say, if you're catching your NN, leave it out and come back to it afterwards. 6 marks, you could afford to get 6 marks somewhere else and come back to this and waste time. So at a stationary point, dy dx is equal to 0. So we're going to let 6x minus 6 is equal to 0, 6x is equal to 6, and x is equal to 1. When x is equal to 1, y is equal to this could be minus 2. Y is minus 2. That's from the data. Yeah, I most believe so. That's the only way I can see us doing this. Minus 2. Substitute x is equal to minus 1 and y is equal to minus 2 into y is equal to 3x squared minus 6x plus r. Minus 2 is 3 into minus 1 minus 6 into minus 1 plus r squared. Minus 2 is equal to, that would be 3, that would be 6 plus r. 6 and 3 is 9. Minus 2 minus 9 is minus 11 is equal to r. And hence determine the function y. So therefore, I find out what p is, I find out what q is, I find out what r is. So y is equal to 3x squared minus 6x minus 11. And I'm just going to get a quick double check. When x is 1, I expecting y to be minus 2. 3 into 1 squared minus 6 into 1 minus 11 minus 14. Shit. Bam. Minus 6x. X is 1. Oh shoot. Hard luck today. X is 1. So this here could be minus 6x. Okay, good. X is 1. Rub off, rub off, rub off. So you see how I double check it, right? I know something wrong. So I'll go back in my question and see where I went wrong. So it's just a matter of double checking. You work to see where I went wrong. And I went wrong because I substituted x is equal to minus 1 instead of x is equal to 1. So this could be 3 minus 6 plus r. 3 minus 6 is minus 3. Plus 3 minus 2 plus 3 is 1. Plus 1. So again, I'm going to double check my work. When x is 1, I get 3 minus 6 plus 1 minus 2. So we're good to go. Alright? So this is a mad question, right? This is a mad question. Me, I like it. I like it, but me, I like it. Right? So I will assume your calculus question is going to come a little challenging. Let me just hope and pray it here comes this challenging. But like I say, we are frightened. It have ways to double check your work and make sure you're going on the correct track. Still on the same question? We now start number 4. So number 4 had calculus and some velocity time graphs in it. Alright, no scene. Part C. Figure 1 shows the velocity time graph for 18 seconds of the journey of a car. The journey is made up of 4 sections: A to B, B to C, C to D, and D to E. So it's velocity time. No scene. Well, I already see what the first part is, but whenever I see a question like this, regardless if they ask you to describe what happened at certain intervals, the first thing you should do is try to describe what happened at certain intervals. Understand what the graph means. So, part 1. So I see in B and C, C and D, and that's it. I still gonna explain everything. So part 1, B and C, between B and C, B and C is a vehicle. The car is decelerating. Because if you realize, from B to C, his velocity is going downwards, which means he's slowing down, which means he's decelerating. Between C and D, the car, two things happened here. Maintained a constant velocity. It was at rest. Okay. The car is at rest for 3 seconds. Now I'm going to explain what the rest of things mean, right? From A to B, the car is not at rest. The car is traveling at a constant velocity. There is zero acceleration. The car is traveling at a constant velocity of 20 meters per second between A and B. Between B and C, the car is decelerating, and we can use the gradient of the line to calculate the deceleration. Between C and D, yes, it's another straight line, which means that the car maintained a constant velocity of 0. If you maintain a constant velocity of 0, it means you are at rest. And from D to E, the car accelerated up to a velocity of 25 meters per second. Alright? Yes, Salim, very good. Is decelerating constantly or has constant deceleration? Alright, thank you very much. Alright, let me see what the question asks now. Aha. Calculate the acceleration of the car between D and E. Alright, so this is part 2 or part B? Part 2. Acceleration. You can use your formulas if you want. You can use v is equal to u plus at. But I mean, you could use the gradient of the graph as well. Acceleration is equal to rise over run. I wouldn't say that yet. Is equal to the gradient. Acceleration between. Did they say between? I'll just scroll down and scroll back up. The acceleration, yes, they said between. So the acceleration between D and E is equal to the gradient of DE. If you want, you could use the formula y2 minus y1 over x2 minus x1, or make life easy, rise over run. Of make life nice. Vertical distance over horizontal interval. All those All those formulas are acceptable. So my vertical distance will be from E to 0, which will be 25. Over my horizontal interval is from 12 to 18, and that looking like 6, 12, 1, 2, 3, 4, 5, 6. 25 over 6. 25 divided by 6. 4. Put in a fraction, man. Actually, I'll leave it like that, right? 4.1667 meters per second squared. Not bad. It's back in the middle here. In which of the 4 sections of the journey does the car cover the greatest distance? Justify your answer by calculation. Well, we know that our distance covered is equal to area under the graph. So part 3. I'm going to grab this image and bring it across. Give it a second. Let it load up. Grab this again. See if it. Nice. Alright. So we know that how distance traveled is equal to the area under the graph. Now if you're altering the diagram, just make sure the examiner can see the word let. So we have 4 intervals here. A to B, that will be one interval there. B to C will be another interval. C to D be another interval, and then D to E will be another interval. Because the car was at rest between C and D, here cover no distance. So I just have to calculate the area of A1, A2, and A3 and see which one gives me the biggest area. So the area of A1 is equal to the distance traveled. And what did they say? In the first section. I will put from A to B. And I'm going to say in the first section, distance traveled from A to B. So the area of A1 will be, this is a quadrilateral, base by height, length by breadth, 20 by 4. That is 80 meters he traveled. The area of A2 is the distance traveled from B to C. That is half base. That is what? 1, 2, 3, 4, 5 by perpendicular height, which is 20. Half of 20 is 10. 10 fives are 50 meters. The area of A3 is equal to the distance traveled from D to E. Again, a half base. We established this as well. 6. 1, 2, 3, 4, 5, 6. A half of 6 by 25. Right, so that is half of 6 is 3, 25 by 3 is 75 meters. What I want you all to do if you have questions like this, don't neglect CD. Let the examiner know that you know what's going on with CD. From C to D, the car was at rest. Hence, no distance was covered. Or you can say something to that effect. So we can safely say that in the first section, or from A to B, the car traveled its greatest distance. So from A to B. Now because the question said 4 sections, I'm going to put section 1. From A to B, the car covered the greatest distance. And I could put 80 meters in brackets here. Easy peasy lemon squeezy. I mean, that was an easy question. Number 5, integration. So we are an hour and a half in and we're done on number 5 already. So we have about an hour change again to do 2 questions. Find the following integrals, giving an answer in its simplest form. So the first one is an indefinite integral. The integral of 2x plus 1 cubed dx. If you want, you can go ahead and expand it, integrate each term. If you want, you could use your substitution. Because they say in its simplest form, either method you use, break it down in its simplest form and you're good to go. Let t be 2x plus 1. So dt dx is equal to 2 and dx is equal to dt over 2. So I'll have the integral of t cubed with respect to dt over 2. So I'll get t to the power 4 over 4 and I'll multiply by 2 plus c, where c is a constant. Replace t with 2x plus 1 to the power 4 over 8 plus c. That's it for A, part 1. Part 2, we go do it next here, next door. The integral of 7x cubed minus 1 all over root x dx. Now, a lot of students could be like, well, product rule, quotient rule. That's a very easy way to attempt things like this. Come in, we work in column. I'm going to consider 7x cubed minus 1 all over the root of x. I could break this up. There's 7x cubed all over the root of x minus 1 all over the root of x. Using my laws of indices, the root of x is x to the half. So this is 7x cubed over x to the half. Take away 1 over x to the half. Laws of indices, again, this will be 7x to the power 3 minus a half minus x to the minus a half. Simplified further, I get 7x to the power 3 minus a half. 3 take away 1 over 2. Express it as an improper fraction. 5 over 2. Take away x to the power minus a half. So this integral is actually the integral of 7x to the power 5 over 2. Take away x to the power of minus a half dx. Easy stuff. This becomes 7x 5 over 2 plus 1. An easy way for you all to do it. The denominator is 2. If I'm adding 1, 5 over 2 plus 1, 1 is the same thing as 2 over 2. The denominators are the same, so I just add the numerator. So that is 7 over 2. Divided by 7 over 2. Take away x to the power minus 1 over 2 plus 2 over 2 becomes 1 over 2. X to the power 1 over 2 divided by 1 over 2. If I'm dividing by a fraction, I must invert and multiply. So this becomes 7x to the 7 over 2 multiplied by 2 over 7. Take away x to the power a half multiplied by 2 over 1. Plus c, sorry. Make sure and write where c is a constant. This is the working column here. The 7 cancels with the 7, and I end up with 2x to the power 7 over 2. Take away 2x to the power of a half. Replace this here with your laws of indices. Bring it back into squared form. This is 2. The square root of x to the power 7. Take away 2, the square root of x plus c. This was a little challenging one, I would say, for students who don't practice their indices. It's worth 5 marks. It definitely worth 5 marks. So if you know you're rusty on your indices, go back and practice your indices, please. Right? Indices will save a life in this question. Next, part B. Figure 2 is a sketch of the graph y is equal to 2 sine x in the first quadrant. Cool. Using an integration method, determine the area under the graph in the first quadrant bounded by the x-axis. Dinosine. One time I could develop my integral, it will be the integral between pi, I could put area, is the integral between pi and 0 of 2 sine x with respect to x. Again, if I have y is equal to cosine x, then dy dx is minus sine x. So when I'm integrating sine x, I get negative cosine x. So this becomes minus 2 cosine x evaluated at pi and 0. This is minus 2 cosine of pi minus 2 cosine of 0. Cosine of pi, go on your calculator if you're unsure. Even if you're sure, go on your calculator. Cosine of pi is minus 1. So this is minus 2 multiplied by minus 1. Take away. Please don't jump the gun when you have things like this and say, well, you know, minus 2 minus 1 is 2. Please take your time. It wouldn't take you 10 seconds. Just write it out. Take away cosine of 0 is 1. So this is take away minus 2 multiplied by 1. Minus 2 by minus 1 is 2. Take away minus 2. That is 2 plus 2. And we get 4 square units. This is the last one here. Yeah, the last question here. This is our next is a kinematics question. So I actually like how they're breaking up the questions in this paper. A particle moves in a straight line so that its velocity k from a fixed point is given by the equation that, where t represents time in seconds. So I'm going to write down what k is. So the velocity, they say the velocity is k in this case. So k is equal to 2t cubed minus t. Now again, just like how I had my special working box, I'm going to develop a special working box for this one as well. For the sole purpose, this is classified. For the sole purpose of writing velocity is equal to 2t cubed minus t. Because I like to go on track with SVA. Alright? You see how they assign velocity, displacement, and things as different letters? That is just there to tie up. When t is equal to 3 seconds, the particle has a displacement w of 25 meters. So, when t is equal to 3 seconds, w is equal to 25 meters. So one time in my special working column, when t is equal to 3, s is equal to 25 meters. Determine an expression for displacement from O for the particle, and O is SVA. I have velocity and our displacement. I have to integrate with respect to t. So S is equal to the integral of V with respect to t. If I carry this across up here now, W will be the integral of K with respect to t. So W will be the integral of 2t cubed minus t with respect to t. W is equal to 2t to the power 4 over 4 minus t squared over 2 plus c, where c is a constant. I could cancel off here, bam bam, I get 2. We have the condition when t is equal to 3, w is equal to 25. So we have 25 is equal to 3 to the power 4 over 2 minus 3 squared over 2 plus c. 25 minus 3 to the power 4 over 2 plus 3 to the power 2 over 2 is equal to c. Jump on my calculator. If you want to work it out one time, you could work it out one time, no problem in that. 25 take away 3 to the power 4, delete 3 to the power 4 over 2, bam, plus 3 squared over 2 minus 11. So W is equal to t to the power 4 over 2 minus t squared over 2 minus 11. This was not bad kinematics question. And I think this is the last question here, the statistics. Oh, it's a big statistics question. Alright, statistics question is with 20 marks. I know, see. Let's see what we can do. Alright, number 6, part A. On a lower 6th form, there are 43 students who are studying either statistics or physics or both statistics and physics. 28 students study statistics and 19 students study physics. If a student selected at random, determine the probability that he or she is studying both. Okay, cool. Now, if you look at this, right? Given that they said that of 43 students who are studying either statistics or physics, or both statistics and physics, this is telling me that I'm dealing with that set of students. The set of students I'm dealing with is 43. So the number of students in this class is 43. So I can safely say that the number of students, first let me develop terminologies. Let P be physics students, and let S be statistics students. We know that the number of students in P union S could be 43. The number of students in physics is 19. And the number of students in statistics is 28. We have the formula. The number of students in P union S, this is for part 1, is equal to the number of students in P plus the number of students in S. Take away the number of students in P intersect S. P intersect S is what I'm asking for. So the number of students in P union S is 43, is equal to 19 plus 28. Take away number of students in P intersect S. Rearrange 43 minus 19 minus 28 is negative the number of students in P intersect S. Where is that? Minus across here, yes. 14 minus 19 minus 28 is 43, sorry. Minus 19 minus 28 is minus 4 minus n of P intersect S. So the number of students in both physics and statistics is equal to 4. And we can say this is the number of students who study both statistics and physics. Both S and P. Now my first thought for this question was to draw a Venn diagram, and it's no problem if you want to draw a Venn diagram for this. Odds are it will help you. Alright, part 2, they want the number of students in physics only. The Venn diagram will help you in this big time, so I'll do part 2 right here. If I draw my Venn diagram, draw my first circle there, copy this fella here, paste them there, intersect them. We know they're intersecting because the number of students in physics and statistics is 4. Alright, other one, the probability. Okay. Whew, we are finished yet. So the probability of students studying both physics and statistics, that will be still, it will be P intersect S, could be 4 out of 43. Right, sorry about that. So P S universal set is equal to 43. Now everybody studying something, everybody studying physics or thing, it have nobody in the complement of the set. They say physics is 19, so 19 minus 4 is 15, and statistics is 28, so this could be 24. So the number of students who study P only is equal to 15. So the probability of students who study P only could be 15 over 43. Right, that wasn't bad. Nice 6b now. A tetrahedral die has 4 faces. Brother man, I'm gonna reword this question as I read in it. A dice has 4 faces. 2 dice, a red and a blue, have faces 0, 1, 2, 3. So my 2 dice, one of the dice is red, one of the dice is blue. So I'm gonna say my red dice here has faces 0, 1, 2, and 3. My blue dice also has faces 0, 1, 2, and 3. The dice are rolled and the numbers face down on the 2 dice are recorded. R is the score on the red dice and B is the score on the blue dice. Compute the probability that R is 3 and B is 0. So part 1. The probability that R is equal to 3 and B is equal to 0 will be the probability that R is equal to 3 multiplied by the probability that B is equal to 0. If I roll and I get a 3, the probability of me getting a 3 is a quarter. The probability of me getting a 0 is also a quarter. So a quarter by a quarter is 1 over 16. That wasn't bad at all. And part 2. Remember, Anders multiply. Okay, sample space diagram. Right, so I'm just gonna bring the diagram across. Right, copy and complete the diagram. Okay, so this is just like a little row by column, like a little Sudoku, but we multiplying rows by columns going up the road. So over here, this could be 0 by 0, 0 by 1, 0 by 2, 0 by 3, 1 by 0, 1 by 1, 1 by 2, 1 by 3, and so on. Because they did say that T is R multiplied by B. So this could be 0, 0, 0, 0, 1, 2, 3, 0, 0, 2, 4, 6, 3, 6, 9. These are all the possible outcomes we can have. Three marks. Part 2. Okay. Part 3. The table below gives the probability of each possible value of t. Alright. Calculate the values of A, B, and C. So this table says, look at the second column. The probability when t is equal to t. So for the first one, for 0 and A, that's the probability when t is equal to 0. So the probability when t is equal to 0 is equal to 1, 2, 3, 4, 5, 6, 7 over how much in the sample space? 16. The probability that t is equal to 3. We have 2 3's in the sample space, 2 out of 16, which is 1/8. And the probability that t is equal to 4. We have 1 in the sample space, so that's 1 out of 16. Easy. Yes, Sammy, this is a giveaway marks kind of question. Let me just hope and pray. Our statistics and probability question. Well, the probability part come easy. And I seen the statistics part is a stem and leaf, so real easy. Stem and leaf and box and whisker is a lick up thing. The number of cars, right? Nice. Determine the median and quartiles for the data. Watch this here. Bam, bam, bam. I'm bringing this across. You don't have to use no big set of formula and thing in this, right? Median is the middle value. We could do that from long time now. First with last, first with last, first with last until we end up with the last value. First with last, first with last, first with last, first with last, first, 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 last. We end up with them today, like 41 and 43. So Q2 is 41 plus 43 divided by 2. 41 and 43, that is what? 84. 84 divided by 2, 42. Hey, 42 is between 41 and 43. Yeah, pure maths lesson starting in August. If all you want, all you have a number 793-4754. Message me and book your spot. Alright? I miss a 3. Oh shucks, I miss a 3. Do over. One time. First, last, first, last, first, last, first, last, last, first, 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 last. So Q2 is 41. Now Q1 is the median of the first set of values. So I'm not going to include this fella here. I'm ignoring him. My first set of values run from 10 to 41. So I'm doing the same thing again. First, last, going down the road. And I'm doing the same thing for Q3. So for Q1, first with last, 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 first with last. Q1 is 33. Next, first, last, 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 52. Q3 is equal to 52. Now, they say quartiles, right? I think they want no interquartile range. There's 3 marks. We have an interquartile range. 3 marks. 1, 2, 3. Now, if you want, you could use your stem and leaf. If you want, you could actually list them all out. Right? No problem in that. But if you show this here, I do see why they wouldn't give you no marks. You get your marks. Next, construct a box and whisker plot to illustrate the data and comment. Jesus Christ. Lick up thing by jeez and ages. I'm gonna move this across. Again, pure math starting in August. So, I draw a little number line underneath here. Now I want to draw my box and whisker plot as accurate as I can. Right, I mean, all I go draw it more accurate than me. Let me see. So Q2, let me say Q2 is 41. I put 41 closer to 33. I want that boy. My 2 lines on the end. Let me see. 41 minus 33. 41 minus 33 is 8. And 52 minus 41 is 14. So you're closer to this side here. So there's 33. This is 41. And this is 52. Is it? Describe on the shape. This is what, positively or negatively skewed? This looks like positively skewed. Let me just double check that. Yeah, this is positively skewed. So when they say comment on the shape, all you have to say is that the data is positively skewed. Here's part 2. We just say that the data is positively skewed. Is it? And bam, we done. That was not bad paper. The only bacchanal question was that differentiation question. That's the only bacchanal question. Alright, Talia. So it was nice. We completed the paper in roughly 2 hours. Right, a little less because we talk a little bit and it take a little while for it to start. This video will be going up as soon as I finish the live. I'm going to organize and put it up on the channel. If you have any questions, message me. My number is dong so. Dong de. Yeah, my number dong de. Message me. And yeah, I will see you guys tomorrow. Just now is Copa. Tomorrow, 3 o'clock is finals, right? We will have a class in the morning tomorrow. So I'll have to wake up early on Sunday. About 9 o'clock and so. Look out for the schedule. And I will see everybody on Sunday. Peace.